Hello, everyone. Welcome to the binary episode of the Day Zero podcast for this week. I'm Spectre. With me is Z, who will now cover the Spot the Vuln solution for this week, and then we'll get into topics as always.
Yeah, this week's Spot the Vuln was another one actually inspired. I think it's from Pentester Academy, um, based off of one from there. Somewhat. There's a Python too. I changed it a little bit here. But take a look. The issue here really comes down to one particular line. The line 4, calling this a static method. So what you've got here for our listeners, you've got a authenticator class, and you've got a class that implements the base HTTP request handler. Just has a simple like do get handler, checks if a user is authenticated, has some potential admin stuff they are, basically for a privilege escalation aspect to this. Key thing here, you've got the class authenticator, calls authenticate, gives it the request that came in, it pulls the header out. All of that is basically just misleading. The real issue is when this is a static method, that means that the fields used in it, so on line 11, there's the authenticator.user equals user, assuming they've authenticated correctly. It'll take that user and just assign it to the entire class. So that means anybody else who also kind of logs in at the same time or roughly the same time, you can end up having this race condition between different users setting that authenticator user value, simply because this is going to be shared across every user of the application. So you can just kind of spam the request over and over until you get somebody who logs in just the right pattern with the permissions. Would take a little bit to hit it in practice, but definitely something that, like, these sorts of race conditions do happen. So not the most obvious issue, especially since there's a lot of code there that looks like you could have other issues come in, but it is something that I've seen it come up, not for authentication exactly, but other places of using static values to track state. This particular case is very contrived just for the sake of having it kind of contained. But on the static variables, it's tricky to get it right.
Yeah, and race conditions in the web are always fun to talk about. Rare occurrences that they do pop up, we make sure to talk about them. Mostly we saw them in like CTF type platforms, but yeah, cool challenge.
We've covered them a few times there. I mean, race conditions definitely pop up. It's a fun class of bugs to have. Just, I always say, whenever you have something that's only supposed to happen once, just test for race conditions. So that wouldn't really be the case here. This is a little bit different from that. This kind of has to do with a shared state, but I mean, really, static methods, they're shared. You can always mess with that a little bit.
All right, so let's jump into topics. We'll start off with some bugs reported in Accusoft ImageGear by Talos. We have an out-of-bounds write and a heap overflow. We'll start off with the out-of-bounds write, which was in the JPEG progressive image parser when parsing the Huffman tables for DCT stuff or discrete cosine transform coefficients. Won't go too much into the mathematics here because for one, it'd be kind of out of scope. For another, trigonometry really isn't my subject, and it is a bit of a complex compression kind of thing. So yeah, it's just not really my area. But JPEGs can basically have up to 4 Huffman tables for different things. I think they have DC and AC tables for luminance as well as chrominance for the image information. And the table identifier is encoded in the AC and DC entries in this table. So as such, the parse Huffman function that they detail here will try to check that those identifiers can only be from 0 to 3, since you only have the 4 tables. And going beyond that would be out of bounds. But the problem is they parse those entries from the SOS entry as a 4-bit value. And a 4-bit value can be from 0 through 15 or hex F. So because of that opened up range from having those additional bits that can be controlled, you can end up writing out of bounds to the table. So
Yeah, because of that, and obviously the lack of any sort of bound check after they process it. So when they pull that out into 4 bits, maybe that's just a little bit easier for them to work with, whatever. Pull down to the 4 bits, do the range check to be like, is this still a valid identifier? They're basically just trusting that the user knows what they're doing and is providing, or I guess the image is providing accurate information. And it's one of those disconnects when it comes down to it of just different size variables, and I think we're actually going to see that another time in this episode. Um,
Yeah.
it's definitely a common class of issue.
Yeah. This is one of those bugs, though, where even though the bug, when you boil it down, is pretty like straightforward, the path to getting there is really complex because I mean you're talking about JPEG compression, which JPEGs sound like such a simple thing, like you see them every day, but the compression and behind the scenes stuff that happens there is actually pretty complex. I tried to go out of my way to look up a little bit more on like DCT, just to see if maybe there was some interesting stuff I could talk about there with this topic, but it was just like, yeah, this is way over my head, so
Yeah, I'm
I'm
not sure
just
if
gonna
you'd
skip this.
quite have to go into that versus just kind of having the graph of basically the Huffman compression stuff. Um, oh, no, I've run into it a couple. So the one time I kind of read into Huffman tables was actually during a CTF, and the whole challenge was that your shellcode had to be compressed. They had their own custom Huffman table that had to match against, but other than that, it was basically just you had to reverse engineer the table. But that's about the depth of my knowledge of it goes. Um, I mean, it's one of those things. If you're working on JPEGs, if you're fuzzing a JPEG parser, you're probably going to have to get exposed to it. Um, but in terms of just what you're looking for in terms of a code review or something, that change in size seems to be the big thing to take notice of to me.
Yeah, there is a lot of like dense code in their snippets here, though. So if you were gonna try to like skip the summary, I guess, and try to find the bug yourself in the code, it's pretty tough, even with their annotations. Just because there's so much code in between. So um, yeah, just another one of those cases where it's a simple bug, but there's a lot of depth into the code flow here. We'll get into the second bug that was reported by Talos, which was in the palette box parser when trying to calculate the size of the palette buffer, which it did using the bit depth, which the code refers to as bits required. So basically, they perform a heap allocation to allocate data for the color palette information, which they compute against the depth and the number of bits needed for the palette box's any field. When computing that value, they check if the depth exceeds 8 bits. If it does, it'll return 0 because that's not really supported. Otherwise, it'll return the bit required value, which is mass with hex at 1f, shifted to the left by 1, which is then used to allocate in the heap. When it tries to copy data into that buffer, it'll try to calculate that bit required value using the any field, and it'll kind of loop through the bits until it reaches a 0 bit, shifting to the right by 1 each time. So just doing some bitwise on the field. The problem is they start shifting to the right by 1 before they even do any processing. So it seems to me that this is a case where they should have been using a do while instead of a while loop here or something like that. But because they use a while loop and they start by shifting right away, this leads to kind of an off by 1 issue where a bit could end up getting missed or dropped. And it could end up escaping this loop before a bit is counted and thus end up allocating a buffer smaller than what's actually required. So kind of a weird bit of code
I don't know. I mean, I totally
with the
get where they're
bitwises
coming
going on.
from in terms of writing this one because it is starting. It's basically you right shift it until you have the value 0 as like until all the bits are 0, basically. Um, that as a little sort of bit hack to figure out how many bits were needed seems fine. It's just it does always escape 1 early because it does the shift and then increments in the loop body. And because of that disconnect, doing that shift, as you were saying, does that shift early, only increments in the loop body after the condition has already been checked. So every time it hits 0, it no longer increments it 1 more, leading to that off by 1 every time. But
Pretty
as the
subtle
code,
bug.
I don't think it's too weird. Like it's just a little hack to count the bits. I mean, I'm not even sure how else you would really want to conveniently count the number of bits needed. Besides doing this sort of bit shifting. I mean, I guess you can go and compare like maximum values, get the value and just figure out what the highest bit of that would be, but oh no, this feels like a nice solution to doing it. Just the fact it kind of just leads also to that classic off by 1 scenario where your loop and your iteration doesn't quite match.
Yeah, it's a very subtle bug because you have to look closely at the loop itself to spot the bug. It's not like just jumping out at you. Yeah, I don't know. I guess the reason I thought it was a bit weird was just because um, I don't know. It's just not super common to see this kind of bitwise in a lot of the reports we cover, but where we're dealing with a JPEG parser, that's why they're doing a lot of like this low level parsing, so it makes sense. But yeah, it's just not the kind of code that we typically see when we're covering binary issues.
I mean, we don't, but that I think has more to do with the fact that a lot of people just aren't processing the direct bits for any purpose,
Yeah, that's
rather
what I
than the
mean.
fact
They're not
that,
doing the low level parsing.
yeah.
Yeah. So two reports in kind of similar areas, but yeah. I will say the Talos reports, I feel like they do like go really long-winded and way too much into some of the code paths, but that's something I brought up before. And another caveat I'll bring up again is, these Talos reports are intended for the developers, not for people really outside of that, area. So that's partially why, but it was a bit of a struggle getting through some of these reports, and I had to do a lot of like external researching to fully understand some of the areas that they were talking about.
Yeah, I mean, their reports, like, they walk through the code. There are definitely benefits to the approach that they take. They walk you through it from basically top down, right down to the vulnerable code. So,
All right. So we'll get into our next topic here, which is a remote memory disclosure in libcurl, but only on 64-bit Windows. This was reported on HackerOne by NSQ11. As you can probably guess, with the fact that this is only a problem on 64-bit Windows, the root cause is related to integer sizes, and Windows having long as a 32-bit width integer instead of 64-bit, like every other piece of software on Earth, basically. And because of that, it's easy for developers to assume that a long is 64 bits, when on Windows you kind of have that gotcha that it's still 32-bit on 64-bit operating systems. And so assumptions when it comes to using long with sizes can be broken, because when you have like a size T, that is going to be 64 bits on Windows. So here in the add HTTP post function, there's integer truncation that happens when it tries to store the buffer length, which is a size T, so 64 bits. It tries to store that into a buffer length field, which is a long. And because that's 32 bits, not 64 bits like the developers probably were expecting it to be, if you can send a file that exceeds the max size of a 32-bit int, you can cause that length field to be set to -1, which gets interpreted as a magic value, that the program thinks, okay, we don't know what the length is, so let's calculate it using strlen. But that allows for uninitialized memory to get sent because it'll just keep reading past the end of the buffer until it reaches a null terminator, which could be a couple bytes after the end of the buffer or many bytes after the buffer, depending on what's there. But bottom line is you get memory disclosure through libcurl, and it's remote, which is pretty significant. So
yeah, it's definitely a fun scenario to kind of end up in. It is a bit of an ask to say that an attacker needs to control the data size of a curl post upload. So this isn't like you upload a random file. This is like the application you're interacting with uses libcurl, and then you control that size. Bleaka in chat asks, isn't the compiler or cry about that? I mean, integer truncation. In this case, no, and that's because they typecast it to the long, so they're silencing the warning by saying they're intending to do this. But normally, if it was just an assignment to the long, assuming they weren't disabling warnings, yeah, it would. Um, yeah, I believe you should get a warning on that one. But with the typecast, it basically will silence that. Coming back onto the bug itself, I do think it is a bit of an ask for this situation. It does feel a bit weird. I guess I'm saying it's a bit of an ask now. If you were listening to our last episode and we were talking about the GitHub issue, where I'm like, oh no, that could probably happen. This feels more likely than that one, so take that as you will. But um, there's no immediate place that I really think of this, like having this level of control, especially because you need to upload like a four. The main place I could imagine is like you upload a file, it sends it off to another server. And in that case, one, are you going to have control to see this content that it's reading and sending extra? If it's just sending you off to another server, that's probably not somewhere you control. There's going to be a lot of things to actually take advantage of this, but being that it is in a library, it is still a concern and something to be fixed. And it is an interesting case just because of that difference on Windows. And again, kind of thing you can look for is that change of size or change of type in this case. And figuring out the consequences of that. Because yeah, long is not size T.
It does seem really weird that the structure would even have the field as a long at all. Generally, when it comes to like sizes or anything that uses a size T type, you do not want to change that type. You just keep that type going all the way through. It could be the case that maybe there was some old code that was written, or there was merging of new code and old code, and they just didn't want to rewrite the code that used long, so they just did the quick cast to get around it. But that's exactly how these kinds of issues pop up, and it's why you generally want to keep your types consistent, especially when it comes to sizes. So
I could
that's what opened
imagine,
up this issue.
yeah, I could imagine this definitely being, as you were just saying, that old code idea. Um, just the idea, that post structure, what could have been something written very, very early on. I don't know exactly how old curl is. I'm just going to look it up here, but because I think size T only came in with like C99. Um, so if curl,
That's a fair point to raise,
yeah,
actually.
and
Yeah.
curl does predate that. It's curl was initially released in 1996. So it could be a legacy code aspect. Nobody really thought about the security consideration, especially because it really kind of happened over time. Have the introduction of size T, then also 64-bit becoming more common. Like nobody was probably just looking at that code and thinking about it at the time. Like that code in theory, I don't know how old the code actually goes, but just with the typecast there would have worked on like 32-bit for a long time too. So assuming they started using size T immediately with C99, which I doubt, but assuming that, there wouldn't have been any problem until you also hit the 64-bit. So it's been around for a while still, but yeah, I don't know. I'd see this as likely just being old code, as being part of the reason for it at least.
Yeah, multiple changes over time kind of made it exploitable. So yeah, that's a fair and charitable view of it for sure. But yeah, I mean, as far as integer truncation goes, it's one of the like easier issues to exploit typically. And in this case, like you're just getting an info leak, so there's not really much setup that has to happen on the attacker side outside of getting in the scenario that Z described earlier. So, uh, yeah,
Yeah, and I guess there is
pretty good report.
one other consideration there, which being that the attacker also needs that curl buffer length to be at least the 32-bit max. Or no, yeah, 32-bit max. They need to be able to hit that also, which again could be another bit of an ask to have that particular configuration set.
Yeah, I'm not sure what the default configuration would be because I haven't really used LibCurl. So, uh, yeah, hard to really comment on that aspect. But again, another fair stipulation to bring up. So, all right, we'll move into our last topic here, which is a kernel vulnerability in the Linux kernel in NetFilter, which is kind of what it sounds. It allows you to write like filter rules and stuff that you can run on sockets. It's typically like a privileged kind of area. You need CapNet admin to be able to use it, but because of the infamous and dangerous functionality of user namespaces, an unprivileged user could actually use this vulnerability for privilege escalation still, because you can give yourself fake root and fake capabilities and still reach this code. So, yep, this is in NetFilter. I'll let Z jump into this issue because he adds a bit of a better summary on it than I do. So,
well, somewhat of a bare summary. Yeah, and I've just pulled up the actual code for this one too. Which I guess the link isn't actually coming up for those of you in chat, but I'll try and add that to the show notes at least. But the issue is this on line 66 of the file where it does this hits the rule action entries and does the context num actions plus plus. That increment is kind of its assumption that basically there is going to be other entries in here. And the size of this whole array is basically defined based off of the number of immediate expression types that were part of like the rule chain or whatever. The problem being that assumption being is that basically there's these immediate expression types, usually immediately preceding one of these dup or forward rules that are going to be offloaded to the hardware. So this is particular NetDev offload, so it's offloading these rules to hardware. That detail isn't too important, but for a little bit of context. So it's expecting that all of these things, basically, every rule is going to have some of these expression or entries to it. If you manually create the dup or forward rule that does not have a corresponding immediate expression, this increment can end up just going out of bounds and kind of just keep incrementing it because it's assuming this relation that isn't actually enforced anywhere, which ultimately is the fundamental issue on this one.
So it's kind of just that unconditional array access incrementing that's happening there. And again, it's a bug that isn't immediately obvious if you just look at the code and aren't aware of the context of that assumption that they're making, that there's always going to be like a tuple attached to it or whatever. You kind of have to look at different areas of the code and put it together to see what the problem is. If you're just looking at this function in isolation, it doesn't really tell you very much. I guess the context num actions plus plus and the array access is a bit of a code spell. Like if I was doing a code audit and saw that, and I'd be like, okay, I'll take a look at this,
Yeah,
maybe
I
make a
mean,
note of that line, but I wouldn't immediately go to like there's a bug there. So
yeah, it just tells you that they're assuming like there's a relationship between these values that may or may not actually exist. So it would be an indication that, okay, you should make sure you can't violate that in some way. But that's all it's really saying. Like, it is a bit of a smell, but it's one of those things that you have to look further. This code itself isn't enough to necessarily note the bug.
yeah, you have to do some digging. All right, but that's basically all the hard topics that we have. Z, I think you have a shout out, and then we'll move into wrapping up the show.
Yeah, I had one shout out. I guess I'm a little bit late on this one because it's from the 13th of February, but an overview of GLIBC heap exploitation techniques. I'm always into seeing some of these heap things, so this one, it really is just an overview of some of the basic terminology. There's some of the basic primitives, I guess, that you might be using, or areas of code components that you might need to know about. But then it basically just walks through all of, I'm not going to say all of them. I didn't actually go and compare if it has every single attack that I can think of, but it had everything that I thought to control F when I was looking at. So covers them, talks about, when they're patched, if they're patched, and gives the basic idea of all of the attacks and just a great overview of them. If you're going to learn, you might want to, reference this, but you'd probably want to play around with them a little bit more, something like Shellfish's how to heap thing. Or Heap Lab, the course from, I'm forgetting his name. There's a course I've recommended before on Udemy about heap exploitation. Max Camper, that's the name. You'd probably want to go with something like that for learning them, but as a reference for like, here's the gist of some of these attacks, and find if you're in a scenario where you need to go with a heap exploit, or at least want to explore it, giving a look and giving a reference to the gist here to see what do I need for this, what are the requirements, and what can it do, and see if that sort of primitive can help you out. It seems like a great reference for that, so I want to give it a shout out.
Seems like there's some good diagrams and annotations here too. I do kind of find it a little funny that they did ASCII diagrams. Like you can see, it's using dashes and pluses for the boxes. It's using like ASCII flow or whatever, but they're images. So kind of sucks that you like they're ASCII diagrams, but you can't copy or anything in them. But
Same
nonetheless, like
deal with the
they do seem,
code.
yeah, uh, should be illegal. Just kidding, but they do seem like useful nonetheless. So yeah, it seems like a pretty good reference point for if you're looking at glibc stuff. So cool. But yeah, I don't have any shoutouts, so I guess that's where we'll wrap up the episode. Thank you to everyone who tuned in. The VOD will be up on Twitch immediately or on YouTube and other platforms tomorrow. Feel free to follow our Twitter and join our Discord for notifications for when we go live, or if you want to talk about stuff there too with others in the community. We'll be back next Monday and Tuesday for the Bounty and Binary episodes, respectively, and we'll see you next week.